Today we are here to present our minor project on the role of IoT in transforming manufacturing systems, which is presented by Divyansh Singh Bist, Piyush Jain, Himanshu Vishwakarma, and Sahil Jadhao from Mechanical and Automation branch, which was done under the supervision of Dr. Surbhi Upadhyay, which is Assistant Professor of the Department of Mechanical Engineering. Next slide. Contents. We have divided this PPT into different parts such as introduction, literature review, methodology, case study, limitations and future scope, and conclusion. Next slide. Introduction. The IoT introduction, which is also known as Internet of Things, is revolutionizing the industry by connecting machines, sensors, and devices, which is also referred to as Industry 4.0, which is used to share data in real time and act on it also. IoT turns ordinary equipment machines into an automated machine, which which is used to predict failures, reduce downtime, and improve efficiency into smart data-driven systems enabling real-time monitoring automation. Next slide. Now, history of IoT. History of IoT is divided into five eras. The first era was early mechanical, which was before 1980s, which focused on simple machines and manual motoring. Now, the second era came, which was automation and CIM, which stands for Computer Integrated Manufacturing, which was 1980s to 1990s, which introduced microprocessors, PLCs, which is Programmable Logic Controller, and SCADA, which is a systematic control and data acquisition system. Then after that came M2M communication, which was during the time of 2000 and 2010, which introduced embedded systems and industrial Ethernet. After that came the birth of IoT, which was during 2010 to 2016, which introduced industrial sensors, RFID, cloud computing. After that, in which we are currently in, came Industry 4.0 and Advanced IoT, which is during the time frame of 2016 to the current present era, which introduced AI, artificial intelligence, and digital twins. Now, objectives. This project aims to study the role and importance of IoT in modern manufacturing processes while understanding its benefits, challenges, and limitations. Explore industrial case Second, explore industrial case studies and real-time applications of smart manufacturing. Third, provide insight into future trends and innovations in IoT-driven manufacturing. Next slide. Thematic synthesis. A. Architecture and protocol. These work these works describe layered IoT architecture, which is perception, network, processing, and application, and industrial standards such as RAMI 4.0, OPC UA, and MT Connect. They compare communication protocol and show how edge computing and time-sensitive network reduce latency. B. Applications, which is predictive maintenance and quality traceability. Multiple papers show predictive maintenance as the leading IoT use case. C. Advanced manufacturing and additive manufacturing. IoT can enable remote monitoring and automation of AM, improving customization and reducing waste. However, AM still faces scalability and reliability issues. D. Edge versus cloud processing. Edge computing processes bandwidth and latency, enabling local and timely response. Cloud supports heavy analytics and global collaboration. Hybrid edge cloud architectures are favored in IoT environment. E. Socio and economic, Socioeconomic and organizational impact. Discussions include workforce displacement, the need for reskilling, SME, adoption barriers, ethics, and policy. Trust, standard, and ROI are recurring adoption blockers. F. Security and interoperability. Security threats, such as spoofing, DDoS, and code injection, and protocols heterogeneity are major concerns. They suggest solutions include blockchain, intrusion detection, standard framework, which is NIST, but effective industrial deployment remains open. G. Wireless and connectivity roadmap. 5G, Wi-Fi 6/7, and LPWAN together are positioned to meet diverse factory needs such as low latency, massive devices, long range. Deployment complexity and guaranteed QoS remains a research priority in the field of IoT. Now, next slide. This slide will be presented by Sahil. Now off to Sahil now.
So in methodology, we have used systematic literature review approach. We have collected papers from IEEE, Science Direct, Springer, ResearchGate, and Google Scholar. We have included papers from 2016 to 2024, which are peer reviewed. In our screening steps, we have first analyzed the title of our project. Then we have analyzed the 18 papers. We have also analyzed IoT technologies, applications, challenges, and trends. We have also performed thematic comparison across major IoT areas. Next slide, please. This is our first case study, which is based on Industry 4.0 transformation at Bosch Industry. Bosch transformed factories using IoT, AI sensors, and automation. Machines connected with real-time monitoring and predictive maintenance used RFID, digital twins, and edge computing for faster decisions. Bosch has also achieved 25 to 30% reduction in machine downtime. They have improved quality control, energy efficiency, and inventory tracking. Bosch has now become a global benchmark for Industry 4.0 transformation. Now, next slide will be presented by Piyush.
Yes. Our next case study is of Honeywell. Honeywell is a company which provides various products from aerospace and defense system to consumer related products such as air purifiers and fans. In this slide, we will be covering how Honeywell has transformed using Industry 4.0. In terms of maintenance, firstly, it was reactive, but after the implementation of IoT, it's predictive, which means it uses the data to forecast its events. Then data flow, which was delayed in the legacy systems, but now we get real-time data. In terms of quality check, first it was done manually, which takes a lot of time. But now, since it's AI driven, we can increase our pace. About downtime, which was very frequent and now is significantly reduced. Before the model was hardware only, but due to the IoT and Industry 4.0, it has come to hardware plus software and services. Next slide, please. Yes. In this slide, we will be covering about the limitations and the challenges occurred. The first is high initial cost and ROI in uncertainty, since it has the highest heavy sensors and cloud and training. So, in short term, ROI can be very uncertain. Second, legacy system integration, since many of the machines are old. So, we find it very difficult to integrate with the IoT. Third, data management issues. It is because of the lack of standardization causes interoperability and analysis problems. Next, cybersecurity risk, which increased due to connectivity, expose systems to hacking and data breaches. Workforce skill gaps, it is because of the shortage of expertise in AI, analytics, and cybersecurity. Then data overload, since there is so much data, it is difficult to work with it. Then scalability problems. Expansion across multiple plants is very expensive as well as complex and difficult task. Organizational barriers. It is due to the lack of digital culture slow and transformation. Then sustainability concerns because of the rise of electronic waste, maintenance issues, and energy usage. These were some of the limitations and challenges which occurred. Now Himanshu will continue. Himanshu.
So now we will see future scope and considerations. First, which is modular and scalable architectures, which adopt open standards for flexible integration. Second, which is AI and edge computing, which enables real-time analytics and decision making. Third, which is cybersecurity by design, which embeds encryption, intrusion detection, and continuous monitoring. Fourth, which is workforce reskilling, which promotes digital literacy and human machine collaboration. Fifth, data governance and ethics, which ensures transparency, privacy, and regulatory compliance. Sustainability deployment, which use energy efficient devices and eco friendly manufacturing practices. Collaborative ecosystems, which builds partnerships across industries, academics, and governments. 8, which is predictive prescriptive analytics, which move from detecting issues to automatically solving them. And last, which is Industry 5.0 vision, which focuses on human-centric, intelligent, and sustainable production systems. So now we will see the conclusion of our project, which is mainly IoT and Industry 4.0 revolutionization manufacturing by blending technology, human intelligence, and organizational change, and real-time monitoring, predictive maintenance, which has been improved through Industry 4.0, and resource optimization and new digital business models give a competitive advantage. And future outlooks are modular interoperable architectures, AI and edge computing, cybersecurity frameworks, workforce reskilling and human-machine collaboration, ethical data governance, and sustainable energy-efficient IoT deployment. And here are some key challenges for the implementation of IoT. First, which is initial investment, legacy system integration, cybersecurity, skill gaps, and scalability.
So now we come to the end of our PPT. Huge thanks to our coordinator and huge thanks to our mentor, which is Dr. Surbhi Upadhyay ma'am, for giving us key insights in order to create this project. Thank you so much.